All right, good evening, Bearcats. This is Unit 12, Chapter 5, 1, 2, and 3 review. The first problem we have here is a simplify problem. We have cotangent squared theta over cosecant squared theta. Remember, when you have the squared terms, you have to be careful because the first thing you want to probably do is Pythagorean, but you have to be thinking if the Pythagorean is going to help you or not, and if there's a relationship already there. Cotan and cosecant are not part of the same Pythagorean identity, but they are kind of related when it comes to reciprocal identity. So you have to give it some thought first. So if you think about cotan, it would have to do with cosecant, and you could rewrite that as 1 minus cosecant, but I think that would also not give us a cancellation. Cotan can also be written as cosine over sine, and cosecant can be written as 1 over sine, which I think there'll be a cancellation. And some of that just comes with practice. And you could go the other route, but I think the easy path would be to change your cotan. First, we're going to make this fraction bar division. So we're going to write it as cotan squared theta divided by cosecant squared theta. And the next thing I'm going to do is I'm going to write this as a reciprocal identity of cosine squared theta over sine squared theta. And we would be dividing by 1 over sine squared theta. Now I'm going to multiply by the reciprocal, so I would have cosine squared theta over sine squared theta times sine squared theta, and you could put that over 1 if it helps. So our sines cancel, and cosine divided by 1 is still cosine. So we have cosine squared theta, and that is our simplified version. So again, you just have to kind of think through which would give you the quickest and easiest path. All right, let's do another simple. All right, here we have number 2, which is cosecant x times tan x. Again, no squared, so we don't even think about Pythagorean. We're going to go straight to our reciprocal identities. Cosecant can be written, we just did that, as 1 over sine, and we would have x. And tan is sine x over cosine x. This time our sines cancel, and we would end up with 1 over cosine x. Now that's a fraction, so fractions can be made a little simpler. If you look at the reciprocals, 1 over cosine is the same as just secant x, and this is simpler than a fraction. So go Bearcats, that would be your answer. Let's look at another one. All right, for number 3, we have cosecant squared x minus 1 times tan squared x. All right, cosecant and tan, cotton candy for cosecant, tangerine sections for tan. I'm not sure where we're going with Pythagorean identities. Let's start there because this is obviously part of the Pythagorean identity. Cosecant squared x minus 1. That is going to be cotan squared x. If you look at your identity page, you'll see that. So you'll rewrite this as cotan squared x, and then we'll have times tan squared x. All right, these are reciprocals of one another. There's a couple of paths, but the shortest one would be to write cotan as 1 over tan squared x, and we'd be multiplying by tan squared x basically over 1. Cancel out your tans, and you have 1 over 1, which is just 1. And 1 is a pretty simple number, so you have now simplified. So Bearcats. All right, for number 4, I believe the instructions will talk about multiply. Please read the instructions carefully, and if it gives you an instruction to multiply or add or subtract or something, please use that instruction to your advantage. It's trying to give you a hint. So in this case, we have 2 binomials, and they happen to be a conjugate pair. Notice we have tan and plus secant, and we have tan minus secant. So they are conjugate pairs, and you know with conjugate pairs, the middle term will cancel out. So we will multiply the first times the first and get tan squared x, and we'll multiply positive secant times a negative secant and get a negative secant squared x. All right, the next thing we're going to do is we're going to look at what this has to do. This has to do with tangerine sections, but if you look on your identity page, you won't see tan minus secant. So we're going to go over here and manipulate the identity, one of your identities. We will see 1 plus tan squared theta equals secant squared theta. So, or x in this case, sorry. So let's see what we do. If we move secant over so that we have tan, we have 1 plus tan squared x minus secant squared x. At this point, we'd have 0. And we don't want it to be 0. We want just this, so we have to move the 1 over here. When we do that, we're going to get tan squared x minus secant squared x equals negative 1. So this is equal to negative 1. Be really careful about just assuming and not really looking at your identities. All right, let's move on to number 5. Number 5 is a binomial squared, and it will talk about multiplication in your test, so please make sure you're multiplying. Please, please, please recognize that this is a binomial squared, which really means we have sine x minus cosine x times sine x minus cosine x. They are not a conjugate pair because they're both subtraction. Therefore, you can't cancel out the middle term. They're going to be two binomials, and you will have to FOIL them. Or use the shortcut we've learned about all year, which is what I'm going to do. So I'm going to take my little shortcut. And the shortcut for a binomial squared, we take that first term and we square it. So sine x squared, or sine x would be sine squared x. Then we multiply. Remember, we multiply the sine x times the negative cosine x times the 2 together, which would be a negative 2 sine x cosine x. And finally, we take this second term and we square it. A negative times a negative would give me a positive cosine squared x. All right, the next thing we're going to do is this comes up several times in our classwork that we've been working on, where you see in the same trinomial, you see this sine squared x and a positive cosine squared x. So if we were to group those together and move this around and make it sine squared x plus cosine squared x, those two in combination become 1. And that is from your that first Pythagorean identity. So this and this become 1. And then we still have minus 2 sine x cosine x. Doing reciprocals on sine and cosine, you can try that. Won't get you any simpler. And I believe we were in the simplest form. So go Bearcats. All right, let's take a look at number 6. I believe when you get to number 6, the instructions change a little bit, and it talks about factoring. So if it talks about factoring, that means you're going to factor something in those problems. Please read the directions on your test. So if you'll notice, you have a binomial, and we're still trying to simplify them, but we're using factoring to simplify. Notice this plus sign separates the two sides of our binomial, and we have a cosine on the left and a cosine on the right side of it. Therefore, we could factor out the greatest common factor in this case of cosine squared x. So cosine squared x will get factored out, and we'll have our parentheses. So cosine squared x times something will give me cosine squared x. That would be a 1. And then cosine squared x times something else will be cosine squared x cotan squared x. So I need a positive cotan squared x. All right, the next thing we're going to do is we're going to take a look at 1 plus cotan squared x. That's a Pythagorean identity. That one is on your page. And 1 plus cotan squared x is cosecant squared x. So now we have cosecant squared x times cosine squared x. Now when I have multiplication already, usually changing these to the Pythagorean identities is going to just make them more complicated. Usually at this point, when you get to multiplying two terms, you're going to use the reciprocal relationships. Not always, but most often. So let's take a look at what we've got. We've got cosecant. Cosecant could be written as 1 over sine. And cosine squared x, it could be over 1. And if I multiply those together, I get cosine squared x over sine squared x. And when I do that, cosine over sine, if you look at your Pythagorean identities, is cotan. So cotan squared x would be my final answer. All right, go Bearcats. Let's do number 7. Again, I believe the word factoring will be mentioned in this one. At the bottom, there's really nothing to factor, and it's not a Pythagorean identity. But the numerator is one of our Pythagorean identities, and we could switch that, but that would not get us any closer to, I believe, where we want to be. So if it says factoring, then look to factor. This is like a difference of squares, and you may not see that unless you're thinking this. So imagine the secant gone and you really have x squared minus 1. And if you have x squared minus 1, you should recognize it as a difference of squares, x plus 1 and x minus 1. And then we would just insert the secants back in by the x's. So if we take that principle and we use that method, then we would have secant x plus 1 and secant x minus 1. And then it's all divided by, of course, this secant x plus 1. And all of a sudden, secant x plus 1 cancels with secant x plus 1. Remember, because that plus sign, it would have to be matched up. You couldn't just cancel the secant parts out. All right, so we're left with secant x minus 1, and that would be our simplified version. Let's look at number 8. All right, this one's going to be adding and subtracting. Notice we have two fractions and we're subtracting. Whenever you add and subtract fractions, remember you must find a common denominator. And you need to stop and think tomorrow on your test before you just start working things and starting to manipulate things about what it is algebraically you're doing. You have two fractions basically. You're subtracting two fractions or adding two fractions. You need to get common denominators. And in this case, these are not the same denominator because one's a plus and one's a minus. So they're going to both be our denominators. So I'm going to write that as secant x plus 1 and secant x minus 1. All right, to do that, if that's my denominator, then this side has the plus 1. It would need to be multiplied at the top by secant x minus 1. And this has secant x minus 1, so it would be multiplied at the top secant x plus 1. All right, if I do 1 times that, I'm going to get secant x minus 1. And then be really careful about the subtraction sign. You could write the subtraction and then do a parentheses, so you will distribute your negative, or you can take this as a -1 when you distribute, and that's what I'm going to do. But either way will be fine with me. So -1 times secant would be negative secant x, and -1 times positive 1 would be a -1. All right, now what we need to do is clean up the top. We have a secant x and a negative secant x. They will cancel. We have a -1 and another -1, so we have a -2. All right, in the bottom, since it just happens that both of these denominators, are the common denominator here, happens to be a conjugate pair, we're going to go ahead and multiply that together. So secant x times secant x would be secant squared x, and 1 times -1 would be -1. Now you may look at your Pythagorean identity. So we have a -2 over, and then secant squared x minus 1 will be tan squared x. The last step would be to make this as simple as we can. Remember, I said if you can keep it from being a fraction, that would be important. So if we move the tan, if we take the reciprocal of tan squared x and move it upstairs, tan 1 over tan becomes cotan. The -2 doesn't change, and so our final answer would be -2 cotan squared x. And that would be your final simplified version. Be really careful. That's probably the hardest part, is when you have to do the common denominators. Let's look at 9, which is another one of these. All right, for number 9, we have cotan x minus cosecant squared x over cotan x. Here's one of the largest mistakes made, so please do not make this tomorrow. You may not, and I say again, you may not cancel the cotan at the top and the bottom. The top of this is connected by that subtraction sign, so all of this is one piece of information. You cannot cancel those cotans out. What you can do is you can make this one over 1, so again you have two fractions and you're subtracting, so therefore you must find a common denominator. And in this case that would just be cotan x. On the left side, it doesn't have a cotan x in the denominator, so we've put that there. We would also have to multiply by cotan x in the numerator. So we would get cotan squared x. And nothing happens on this side. It already had the right denominator, so we would have minus cosecant squared x. All right, once again, if you peruse your Pythagorean relationships, you're going to find that you don't see cotan minus cosecant. So we need to manipulate what we do see. So if I see 1 plus, so I'm thinking over here, there's my little thinking face, 1 plus cotan squared x equals cosecant squared x. And I want to take cotan and I want to subtract cosecant. I get 1 plus cotan squared x minus cosecant squared x equals 0. And I want just this part. I have to move the 1 over, and when I do, it becomes a -1. So cotan squared x minus cosecant squared x is actually -1. So we have negative 1 over cotan x. And the reciprocal of cotan would be tan. So to make it more simple, I would move it upstairs and make it a tan, and I would get a negative 1 times tan, or just a negative tan x. That would be my simple version. Again, you may really want to think about these adding and subtracting and finding common denominators. I believe those are the most difficult part. All right, now we're going to work into our solving part. So for number 10, we're going to start solving, and we're going to solve between 0 and 2 pi. I just fibbed to you. We are not solving. We are verifying. We are verifying. So I'm going to put a box around the right side. We are verifying. So we pretend for a little while that side does not even exist, and we manipulate this side and simplify it so that it becomes what the left side is. All right, so let's first take cosecant. It's not Pythagorean, so use your reciprocals. Cosecant would be 1 over sine x minus. And I'm not going to do anything about the sign since they would have the same trig function there, and see where we go with this. Put it over 1. But now, just like before, I have a fraction and a fraction that I'm subtracting. I need a common denominator. And this just takes a lot of practice to kind of have a gut feeling about these. The more problems you do, they're all going to be slightly different, so there's no real definite path, but there are some things that become very similar and will feel more familiar to you. So the denominator will be sine x. This side doesn't need a sine x. It had it, so it's just 1. This side will need a sine x. So if you multiply, you're going to have minus sine squared x. Oh, all right. Well, 1 minus sine squared x is a Pythagorean identity. That's going to be cosine squared x over sine x. All right, the next step, again, we've done this in class before with some problems. They're in video, but it's something that we haven't done a lot of. You really want to pay attention. You're not in simplest form, and you're really, the big thing is you're trying to verify you're not in this form yet, and this is what you want. So I'm going to separate my cosine squared up here. I'm going to make this cosine x times cosine x. And I'm going to put one of them over sine, and this one just over 1. So if I multiply the top, I get the cosine squared, and if I multiply the bottom, I would get the sine x. Now, here's what happens. This is my cosine I need at the top, and cosine over sine is cotan. And those are in your reciprocal identities if you will look for those. And now all of a sudden you match up, and you can put your little arrow that you have verified. And you can also tell me, go Bearcats. All right, let's look at 11, another verifying one. All right, number 11. 11 has one of our cofunctions in it. If you will look on your identity page, it has there's a section above the Pythagorean relationships that are where it says 90 minus theta. Well, 90, you know, degrees is the same as pi over 2. So you want to make sure you're somewhat familiar with those. Remember, you have your blue card, so that can help. Those are ones we don't use real often. You may want to write down. And we want to look at what cosecant 90 minus theta is. Cosecant 90 minus theta is, if you look on your identities, is secant theta, or secant x in this case. So now we would have sine x times secant x. Oops, I forgot to box my right side. All right, and now we're just going to use our reciprocal identities. Secant, so we're manipulating this term quite a bit. We've taken it from 90 minus theta to secant theta, and now we're going to take secant and we're going to make it its reciprocal 1 over cosine x times sine x, and we'll put that over 1. Multiplying straight across, we get sine x over cosine x. And sine over cosine, if you look on your reciprocals, are your tan x. And we have now verified that to be true. So the Bearcats. All right, let's go on to number 12. For number 12 is where we start solving, and we're going to be solving from 0 to 2 pi. So let's take a look at number 12. When we start solving, we've got a process that we really need to follow. One, we're going to try as often as we can to have only one trig function. Sometimes we'll have two, but most often we'll have one. We will particularly have one if we have a quadratic, and with that squared term right there, we know we have a quadratic. And with all quadratics, we'll have to set them equal to 0, which is also a big part of our process. And then we will factor to finally get our two factors so we can solve. So the first thing I'm going to do is I'm going to go ahead and try to get 1 trig function, I recognize my cosine squared x as Pythagorean. So I'm going to keep 1 plus sine x equals 2. And instead of cosine squared x, I'm going to write it as 1 minus sine squared x. And now I'm going to distribute my 2. So I have 1 plus sine x equals 2 times 1 is 2. And 2 times negative sine squared x is negative 2 sine squared x. All right, now I have one trig function, and it's quadratic, so I'm going to set it equal to 0. I'm going to move, since I want my squared term to be positive, I'm going to move this to the left, and it will become a positive 2 sine squared x. My sine squared, or my sine x was already there and positive, so sine x. And I'm going to move the 2 over, and it's a negative 2. So 1 and negative 2 is negative 1. Set it equal to 0. All right. If you get lost in the all the trig functions, take a look at this algebraically. Imagine for a minute that this is just 2x squared plus x minus 1. And we were going to factor. Remember, the first two terms have to multiply to 2x squared. So you would have to have a 2x and an x, because 2x times x is x squared. And that's really your only combination. The second two terms would have to multiply to 1. So you have a 1 and a 1, and actually to negative 1. But 1 has to be negative. So if I do the smiley face, is what I call it, or some people call it the rainbow, I take these two and multiply them, I get 1x. I take these two and multiply them, I get 2x. This combination has to be the middle term, which is just x in this case. So I want that this x right here to be negative. So a negative x and a positive 2x would give me my positive x. Since it's this one and these are related, I'm going to put the negative here. And since these are related, I'm going to put the positive here. That would be how I would factor. If you want to use a box or whatever to factor, feel free. So I'm going to go over here, and I'm going to use that, but I'm going to interject my signs. So on my factors will be 2 sine x minus 1 and sine x plus 1. All right, so let's keep going. Alright, so let's go ahead, and they're both set to equal to 0. Sorry, I was checking to make sure I wasn't running out of battery. Alright, so we're going to set each factor equal to 0. So I have 2 sine x minus 1 equals 0. And I have sine x plus 1 equals 0. If I move the 1 over, it would become a 1, and I would divide by 2, and I would get sine x equals positive 1 half. Over here, if I move the 1 over, I would get sine x equals negative 1. Alright, so this is a sine value that is positive. Remember, all surfers to California, sine is positive in the first and the second quadrant. Then think about your chart, the chart. And the chart, where is sine 1 half? Sine, I believe, is 1 half at pi over 6. So my reference is pi over 6. And because it's pi over 6, and we have it in the first quadrant, then that is also one of our solutions. This would be 6 pi over 6, therefore in the second quadrant would be 5 pi over 6. So our x values would be pi over 6 and 5 pi over 6. So there's two of our solutions. And on this side we have sine equals negative 1. So again, sine equal negative 1 would be down here, I believe, at 0, negative 1. This would be my sine value at negative 1. So x would be at, and that would be at 3 pi over 2. And that would be my other solution. So those are my three solutions for number 12. Let's move on to 13. All right, for 13, let's see, I don't see any Pythagorean identities. So what I do see is a term on the right side. So let's move it over and subtract it and see what happens and what it looks like. So we have the square root of 2 times cotangent x times sine x, and then we would subtract or minus cotangent x equals 0. All right, well, we're going to set it equal to 0, and now I see a common factor. And as you see a common factor, then you don't have to worry about changing things. So my common factor would be cotangent x in both cases. So I'm going to factor cotangent x out, just like a greatest common factor. And in my parentheses, I would have to have the square root of 2, and I'd have to have sine x. Because cotangent x times square root of 2 sine x would give me my whole term right here. And then I have cotan times something gives me cotan x. Well, that would just be a negative 1. That's still all equal to 0. Well, now I have two factors, and I can set each one equal to 0. So I have cotan x equals 0, and I have the square root of 2 sine x minus 1 equals 0. So let's solve those. All right, cotan x equals 0. Well, cotan is not one of our primary trig functions. It's a reciprocal function, and it's friends with tan. If cotan is 0, it would be where tan is undefined. And you have to remember on our big four corners that tan is undefined at the top and the bottom. And so that would be at pi over 2 and at 3 pi over 2. So therefore cotan would also be 0 at those two places. So our x value would be at pi over 2 and 3 pi over 2. Alright, next I'm going to come over here and I'm going to solve for sine x. So I would move the 1 over and divide by the square root of 2. So I would get sine x equals 1 over the square root of 2. I would rationalize my denominator, square root of 2 over the square root of 2, and I would end up with sine x equals the square root of 2 over 2. And that's very familiar. So sine is positive in the first and the second. The square root of 2 over 2, that would be where my theta would be at pi over 4. This is 4 pi over 4, making my second quadrant 3 pi over 4. So my x values would be at pi over 4 and 3 pi over 4. And there are two more solutions. So there's my solutions for 13. All right, let's move it on. We're getting close to getting finished. Hang in there. Keep going. Okay, so now we have problem 14. We're still solving, and we have secant squared x equals tan x plus 1. I'm going to take a look at my secant squared x Pythagorean identities. I believe I can change this to 1 plus tan squared x. And I did that because of the tan over here. I'm going to go ahead and write it out. You might can do two steps in one. And now I have a quadratic because of the squared, and I need to set it equal to 0. So I'm going to keep my tan squared x. I'm going to move this tan x over, so it'll be negative tan x. I'm going to move the 1 over. It's a negative 1, so those will cancel out. And therefore, on this side, everything now would be equal to 0. Next, what I'm going to do is I see that both terms have, or both sides of the equation have tan as a greatest common factor. So I'm going to factor out my tan x. And in the parentheses, I'd have tan x times something equals tan x squared, and that would be tan x. And tan x times something equals negative tan x, so that would be a negative 1. All right, no Pythagorean. I'm not going to change anything. There are two factors, both equal to 0. And I'm going to set them equal to 0. So if I do that, I would get tan x equals 0, and I would get tan x minus 1 equals 0. All right, tan x equals 0. I think we just did this. 0 at, it was undefined at the top and the bottom. So 0 right here and right here. So that would be at 0 and at pi. So x in this case would be 0 and pi. There's two answers. And for this one, I'd move the 1 over, and I would have tan x equals 1. Well, tan is positive in the first and the third, and tan is 1 at pi over 4, and that would make this 4 pi over 4. Therefore, this would be 5 pi over 4. So x, or theta, would be pi over 4 and 5 pi over 4. Okie dokie. Getting close. I think we got 3 more. All right, this is a pretty short one. Notice, don't let yourself get too, if you have an easy one sprinkled in sometime, take it as a gift. Don't try to do more than you need to. There is one term, there is no squared, it is set equal to 0, you can just start solving. So you would move the 1 to the right, and then you would divide by 2, and you would get cosine x equals 1/2. Well, that's a pretty easy one. So cosine is positive in the first and the fourth, and 1/2. Cosine is 1/2 at the reference of pi over 3. This would be 3 pi over 3, and this would be 6 pi over 3. And if you went over back to the fourth quadrant, you would be at 5 pi over 3. So my x value is equal to pi over 3 and 5 pi over 3. Yay, go Bearcats. All right, number 16 and 17 have to do with multi-angles, or half angles in this case. This is going to be a 1/2 of theta, and we're going to find half of theta first, then we're going to multiply to find actual theta. We will take away the 2 in the front, but we will not be able to take away this 1/2 x, the 1/2 in front of the x, until after we've solved the first time through. So we're going to divide away by 2 and get cosine, and I'm going to make the x over 2 the same as 1/2 times x, equals the square root of 2 over 2. Well, that's a familiar number, so that's good. And cosine is positive, so positive in the first and the fourth. Square root of 2 over 2 would be at pi over 4. Since this would be 8 pi over 4, that would make this 7 pi over 4. So right now we have 1/2 theta, or 1/2 x, is the square, or is pi over 4, and 7 pi over 4. Now, to get rid of the 1/2, we're going to multiply by 2. So we're going to multiply by 2. We're going to multiply by 2. So now we have x, or theta, is equal to 2 pi over 4, which would reduce to pi over 2. And x is equal to 14 pi over 4, which would reduce to 7 pi over 2. And those are our two solutions. Go Bearcats. Last one. Here we go. All right. Again, there's really nothing to solve. We're going to solve for 2x first, and then we'll divide by 2 or multiply by 1/2 to clear up the 2. And we already are looking at sine and a negative sign. So sine is negative in the third and the fourth quadrant. And then you just have to think about where sine is the square root of 3. Over 2. And I believe that's at pi over 3 is my reference. Now, I'm not in the first quadrant, so I'm going to use it as a reference. So this would be 3 pi over 3, and this would be 6 pi over 3. So that would make this 4 pi over 3 and 5 pi over 3. And you've solved for 2 times our x or theta value. We're going to go ahead and we're going to divide or multiply by 1/2 each thing. So we multiply by 1/2. We'll clear out our 2, so 1/2. 1/2. And when we do, we have x is equal to 4 pi over 6, which reduces to 2 pi over 3. And then we have x is equal to 5 pi over 6. So these would be our two solutions. And go Bearcats. Good night and good luck on your test tomorrow. I'll be here before school early if you need any help. See you later.